Now stop talking. Well, we are discussing about the loading. So this is your load, general, load and definition, load case detail, dead load, and this is your self weight. We have assigned and assumed that at ground level column uh, is not have a significant self weight. So we are not considering. So in dead load, again the other category of that in this STAAD, you cannot take the load of slab or you cannot design slab. This is your major disadvantage. That is, so for considering in frame the load of slab, we have another category of the load, that is your floor load. So I am selecting dead load, again going to add, this is your floor load. So I am clicking on floor load. So this is your just like a auto assigned load combination. Over here the range is provided and the pressure in kilonewton per meter square. So let's say the slab, we assume that each of the level has a slab of 100 mm thickness with the concrete density 25 mm. So what will be the load? 2.5 kilonewton per meter square. Understand? So that is downward means 2.5 kilonewton per meter square. So over here the distribution pattern is given. If you make that one way, okay, then and then it will take the direction of the load distribution only on one direction. Otherwise it is considered the load distribution not in just like our Indian scenario. What is that one way and two way slab definition? Ly by Lx greater than to one way and less than equal to is not scenario just like in other country. So it will basically distribute the load on all four directions unless you specify. Means if you click that one way, that lot of option is available in which direction you want to distribute. By default the longer direction is there. Okay, over here the range is available. I am not giving that one way, I later on correct it and give that the one way. So range, what is that range? So range along that y direction, what is that height of the structure at where to where you want to give. So now for knowing the distance from this level to this level, over here in tool, display node to node distance is available. I am just clicking display node to node distance. So what is this? This node to node distance is 6.4 meter. From this is 3 meter. So this is 3 meter, and from this point to at the top height, that is 9.4. From this point to this level is 3 meter, and from this point to top level is 9.4 meter. So basically the floor is located at the level first. So this is your starting from 3.2 or 3 meter, sorry, 3 meter, and this end with maximum range 9.4 meter or 3 plus 6.4. So along the extension in x and z direction, what is that extension? So this is your z direction, this is z direction, and this is your x direction. Okay, so for looking that measurement in x direction, I am going to front view. So this is your x direction from this node to this node distance 11.66. So starting from 0 to 11.66. So 0 minimum to maximum 11.66. now along that Z direction. So I am rotating this. This is your front view. I am moving to side view. (13.45). So which is that 13.45? Let's look at. This is diagonally it is. This is also diagonal. This both are incorrect. So this will create the problem. So again this 11.66 is incorrect. So for probably checking the front view, I am going to a top view. I am selecting front face of that frame. By stretching window, I am selecting like this. Then clicking right click of the mouse. There you find new view. Creating new window for new view and going to front view. So you will find the face of X. Now I am measuring node to node distance by tool display node to node distance. Now I am clicking from this point to this point. This is 10 meter. So I am rectifying that error I have generated on floor load. So that is your 2.5 minus 2.5 intensity global Y. This is 3 meter and this is your 9.4 meter. This is your X is 0 to 10 and Z. Yes? O. Yes. In Z. Now similarly for looking the dimension in Z, I am clicking this view. I am closing. Now I am checking this frame. So I am clicking over here again by stretch window selecting this frame. Right clicking of the mouse will generate the option new view. Create a new window for view. Again that in this side view. Now I am selecting the tool display node to node distance, then from this point to this point 9 meter. So it is started variation of this. Again it is gone away. So it's better this is Z range is 0 to 9. Now this is added over here and this is your auto assigned load. Since you have defined that range, it is assigned automatically whatever the floor formation along this direction, along this X, Z and Y direction, wherever that 4 closed beam geometry is generated, 4 or 3 closed geometry is generated due to that creation of that beam, where it consider the floor and generate the load and show that load distribution also. Understand what is that load distribution? That is clearly visible or 4 side it is distributing this load. Now I am double clicking that and creating that checkbox, the default in direction of 100. 100 beam is over here in direction of the 100 mm beam, 100 number beam, this distribution goes. So I am making change. So have you noticed that change? Let's I make that another, instead of 100, what is this beam number? 11111. So I am now this is distribution of the load gets switched as a one way, but along that beam number 111. And for L shape of the slab, there is no flow load creation has been formatted. So I am selecting that level, so you can properly see. Selecting this level, right clicking of the mouse, new view with new window, and isometric view. This is automatically. Now let me close that. This is your L shape formation of the floor. So for that you are not finding any kind of the load distribution. Now I am realizing I have to add one beam and make that closed geometry like that. So how will you make that change? So in modeling, this is geometry or view as a whole structure. So what I mean to say that I am going to in top view, I where this is beam over here. So how will you do? Editing. Yes. Okay. So let's have a one trial. I am going to top view, selecting geometry, add beam between which option? By perpendicular intersection. I am selecting this node. I am going to this opposite direction. Now this is formatted. I am going to isometric view. This is randomly generated. So I am making the window option control Z for undo. So I am going front view, zoom out, selecting this geometry at top level or bottom level, creating new window for view, making isometric view. Now adding the beam, geometry, add beam between, now point is available. Now I am closing that and checking at the top level where you find that yes, this is beam is there. Okay. Now you can make copy paste this beam at different level. So for that you have to add the node or how you make that copy paste. So this is very important command for copy paste. Just like a window option, select this beam. very difficult. So I am zooming in, so this width is increased. I am going to this beam. Now this is selected. Now Control C, then now press Control V. Control C for window copy and Control V for pasting. Now this is your paste with move. With move is available. Paste or you want to move or cut and paste is available. Or this is option is by distance following two nodes or by following XYZ coordinate. If you know that absolute coordinate system, then you go through by this system. But one better option is available over here with reference point. So this reference point, I know that over here I will find the node over here. So I am taking the base point like this. Now pressing OK. So this is by default is selected base point. Now I am pressing OK. Now where do I want to copy? Below this floor is this node is there. I am clicking over here. Now this is created. Now another over here. So what I have done that have selected the reference point of this copied beam. So I have considered the reference point over here, and along this line I am finding the node where I can click and paste that beam through reference point of this node. So I have first click over here and this later on this. So now I am going that top view, zooming out. Now this is selected. I am creating new view, new window, and going to isometric view. Only top beam is selected. Again I am going that. What I am selecting this. All three beam is selected over here. 317, 319, 321. New view, new window. So this is like copied like this. Okay. But what is so the beam number is started from that last ended beam number. We have end with the beam number 31. So new is created so that whatever that end of the number, from that it is started, despite of at whichever the floor it occupied. So this beam is 17. Okay, this beam is, let me create. This is 321 at the first level. If you want to make that renumber of this beam, so select this beam, write down for renumbering this beam. In geometry, renumber member. Okay, this is your tedious. So this is for whole beam number. You better you if you want to change this beam number. This is 321. Okay, so probably I want to give at that first level what is that last beam number. So view management at the first level, what is that highest beam number? Probably the number last was at second level 215. So yeah. हाँ એટલે વ્યૂ ચેન્જ થઈ ગયો એમ કરો હા okay. So at this level, okay, at this level, this beam and this beam. This I have added this beam. Ah,
Discontinuous નથી there is real problem આવે તમને દેખાય ને discontinuous
બરાબર છે ને હવે બરાબર renumbering. Now renumber will do by we have not used that STAAD editor. It is non-graphical interface. So I am selecting this at level first. I know that the beam number 321 I have to change to 116. So I am going to STAAD editor 321 beam over here. So this is member incidence. This is member 3 to 1 is connected between 23 to 56 node. I am removing 321 and adding 11. Let me find that 11 is 116. So I am adding over here the number 128 is not available at this level. I am pressing Ctrl S, now closing this. Now for selecting particularly 128, so what is that? Select by list of beam and in which write down that is 128. Select this. This is get now change. So about that, that is your, this is 320. I am closing this. This beam above that is 319 and that you have to change 2 to 8. So I am going STAAD editor. This is in member incidence and that is beam number 319. Now for finding anything written on this is just like a window option, press Ctrl F, and I am writing 229. If anything written on 229, it will find. So there is no 229, or I am giving the 228. So that is 228 is there, beam number is there. So again I am going that this is 36 and 55 node number is renamed as a 229, giving the space, saving that and closing. Now listing that, okay, it's powerful. Now this is renumber is given. So by this way, what is that renumbering disadvantage? For individual beam renumber, this is your better option. And for whole geometry renumber, I am going the renumber of whole geometry. Okay, so this is the renumber. Renumber of node. I am selecting, do you want to proceed? Yes. Please select the relevant entity of renumbering operation. So let me select first node, of which node I want to renumber. I am renumbering whole geometry's node. I am selecting node, then again going to geometry, renumber node. Now in this window, renumber window, there is available sort criteria and selected sort criteria. Available is that like that. So I am making the criteria according to its y coordinate. And ascending order. Then it gives that joint number. Now I am accepting, and I am checking that what is the change. Sorry, I have particular to have to select that node at this level. Let's okay. Let's have a second trial. I am again selecting whole geometry's node. Geometry, renumber, node. So I am selecting the y coordinate and then start number. Okay. I am adding both on this direction. Removing this is on this direction. Z is also in this direction. And over here the start number of node is given. I am giving at 100. Now I am accepting this again, now I am checking that what is the read number happening over here. So this is get changed. Okay. So they have consider according the y coordinate, and then they have considered the whichever the joint number previously have, and then have start renumbering. For better formatting, you have to need to consider x, y, z all coordinate. So this is way you can renumber that node, and similarly you can renumber that each of the level of that beam. Okay. Now let's continue going to that view whole structure, and we were at loading. Now we have added one beam. Now we are finding the distribution pattern. So I am going to that particular level so you can check it, that distribution pattern of this. New view, create a new window, then isometric view. Now this is available. The distribution of that previously for this L shape there was no full load distribution. Now it is available. Now again I am editing. For editing this load, double click. Okay, then make this checkbox as a null, and then apply change. So you will find two-way distribution at each floor level. So this is your triangular, and this is trapezoidal along that longer span. By default, whatever the span is, it will consider two-way distribution of the load. Now this, in other criteria, this external beam of this frame is loaded with masonry whose thickness is 0.23 and density is 19 for a full height. What does that load? Masonry Now height of the story at the first level is 3.2 with the masonry density 20 kilonewton per meter cube, with the thickness of the beam at this level is 300. So 0.3 and a story height is 3.2 meter. So this is 19.2 kilonewton per meter run, that is your load. So that is your member load you have to give at the external periphery at each level. So I have to add this dead load, add in particular category member load that is uniformly distributed, that is minus downward 19.2. Understand how I have considered? This is load is multiply means wall thickness multiply by story height multiply by density. So this is externally loaded this periphery, each level, this level. So I am just adding this. You are finding this is. Now I want to assign each level at external periphery. will you do? So I'm going that top view. Any idea? At top view, by stretch window, I am selecting this beam, creating new view. Now this floor distribution is available to you. Okay. Now for not visualizing this floor load distribution, I'm closing this. The right click, structure diagram, load and result. Not load and result. Let me, that is in label. So in loading display option, this is checkbox is given, display the floor load distribution. So I am unchecking this box. For that keyboard shortcut is Shift plus Y. Shift plus Y. That will disappear the distribution of floor load. Now I am creating that new view by selecting stretch window, I am selecting this beam, then I am pressing Control, then now I am one by one selecting each of the beam at external. Then I am, after selecting this, I am checking the isometric view. So where do you find that below that beam is also get selected? Because I have selected through top view. Understand? At top view if you select, then by clicking one beam it will simultaneously select the beam below that. So now this is selected. Now I am selecting this load, and now I am selecting assign to selected beam and assign. Now this is assigned at external. Now at intermediate level, you will find that load that is have a partition load whose thickness is half. So probably this is 19, so other load is 9.6, half of that for a full height, or for a height of 7 feet. So this is density is 0.20, then thickness is 115, and height is 7 feet, so around 2.1 meter. So this load is 4.83. So that is assigned at internal level of frame at each level. I am selecting dead load. This intensity is calculated 4.83. I am going member load, then this is minus 4.83. Now I am clicking on add button. Now this is added over here. Now I want to select at internal this and this portion only at each level. So again I am going, without going to new view, you can go to into top view. Top view, I am selecting this only beam. Now I am going to isometric view. It is not clearly visible because of that member load distribution. So now you can check that is below that beam is directly selected without creating new view, new window. If you select at top level, below that beam is also get selected. So I am selecting by pressing control. This is also internal, this is also internal, this is internal, this is internal, this is internal, and this is last internal. Now I am checking whether all is selected or not, going to isometric view. Each level internal beam is selected. Now I am selecting, this is uni GY minus 4.83. Now I am making radial button, activate assign to selected beam, assign. Yes, now that is assigned. Now this is your live load. Now live load is generally given by floor load. So it is intensity, let's assume that is your 4 kilonewton per meter, and that is, now I am giving only the Y range. It is starting from 0 to 9.4. I am not giving that X range and Z range. I am closing that. You will find this is automatically assigned. So what does that means? If you give that X and Z range 0, so it will assign this floor load from 0 to 9.4 meter level along that Y direction, and along X and Z direction extension of your geometry. If your multiple structure is there, it will automatically consider at multiple structure at that particular level. If floor is there, it will assign. But we have only one structure, so if you give only Y range, then it will consider along that full X length and along that X full, along the Z length also full. Understand? Understand? Let's make change. I am changing this. I am making this is 0, and I know that extension of X range is 10. So let's give the change. So we will find that warning, cannot generate load for command Y range 00, F load minus 4, X range 0 to 10. So if you give that Y range 00, it will consider at 00 level. At 00 level, there is no floor extension. In case of there is floor is there at 00 level, it will consider along that Z plane whatever the extension of the geometry at 10 meter. When what this means, look at in this geometry, X00 means Y00 means at this level, particularly y00 means at this level. Okay, so it will consider at this level there is no floor, because of the floor definition is formation of the 4 beam or 3 beam that make the closed geometry. Otherwise it will not take that floor load. But at this level 00 level there is no beam that make that closed geometry and form that floor. So let's have make a change and check. There is a one geometry close at 3 meter level. So I am clicking. Now it is, this is extended 0 to 3 meter. Now I am changing. Now you are finding the distribution. So how much geometry it is considered? It throughout along the Z direction. So if you don't give that Z, that will extend the extension of your geometry within that Z range. But the essential is to give that Y range only. If you don't give that, now I am giving, this is your 0 0. Now I am giving it will not make any change. So important is to give that Y range in that your structure. If you give X or Z as the extension of geometry or not, this is not. Why this is given? If I want to assign particularly, let's go in top. At this, if I want to assign particular load within this level, this floor and this floor. So what is this distance? I have to check that first. This distance is this is 4 meter. X is 4 meter. This is X is 0. So this is 4 meter. Okay. I want to give the floor load distribution from range in along the X 0 to 4, along that Z 0 to 6 meter, 0 to 6 meter. So let's make it edit. I am clicking this, I am giving that range. This is 0 to X range is 0 to 4 meter and Y range 0 to 6 meter. I am changing. So range is only meant for partial giving of the floor load. Otherwise, give as a 0, it will automatically assign each and every location. But Y is essential. Understand? Now I have to extend this Y from 0 to 3 instead of 9.4. It is. Now this is not only at this location but each and every floor. So make it better 0 rather giving that full value or given even the higher side value. Okay. So X and Z range is not important for floor load. Now the next is load combination. I am selecting load case and now going to add. This is other way. First way I have show you command loading and load combination, automatic load combination. Now this is your load case detail, add auto load combination, and that is by select or load combination code, that is your Indian code, general structure and generate. I don't like to have these two. I'm simply adding that. Now this is combination is generated over here. Now let's have a something is missing before giving that analysis. For checking is essential. So I have shown you that select something by missing property, missing attribute. So missing property that we are commonly facing that error. So let's click. This to beam is unassigned property. So let's have a assigned to dummy property, that is anything property. Now this two member is assigned with property. Now again I am closing and checking by selecting by missing attribute, property or elasticity. Still one member is there. Now for going to that original location, go to general, click on general, you will find that one beam is unassigned. This is your beam number is 316. Okay, so select the beam by listing beam, that is number is 316. Now select the entity. Now this is selected. Now make this checkbox away. So means that if you uncheck this box and now click on this, it will not highlight the beam over here. Okay, now this property I want to assign. So assigned it, selected, yes. Now why have I make that uncheck box? Now if I want to assign this beam as a 0.3 property, now I am want to go on this location circular column, this will the selected beam is disappear. Only because this means that it will highlight above selected geometry. So that's why I make that uncheck this box and then select one of this property and then select assign to selected beam, then assign. Now tool. Now I am giving that one node geometry node as a dummy node. Zero 3 y is 9.5 meter, z is 0. Now I am closing this structure. Now I am not given any command of analysis. So first it is essential, at first time you have to give that analysis command. So first perform analysis. Now print all. Okay. Now start analyzing this geometry. So you are finding three warning. So let's look into this warning view. What is written? Warning, joint number 115 not connected if part of master slave. Warning, this structure is disjointed, ignore if. And this is, you always find the warning about floor one-way distribution. It will warn you that please note that depending on the shape of the floor, you may have to break up the floor one-way load into multiple commands. As per the Indian Code of Practice, you have defined that if it is Ly by Lx is greater than 2 as a one-way. But it is not a different scenario for this software. It will consider each and every floor as a two-way. In real sense, that is true. But our code is formed to empirical approach, means some exact solution of plate analysis is not required. So that's why I warn you that this software only distribute two-way. So in case of one-way, you have to do it separately. Now about these two warning. Write down, if you find this warning, it is very important warning. Warning, joint number blank. Warning, joint number blank not connected second warning, this structure is disjointed. Now this is both are simultaneously generate in case of orphan node is there. What is that orphan node? Orphan node is unconnected node. Unconnected node. So this is common error you have generated due to that unconnected structure. In previous version, it will give you that there is parallel structure is exists. Now this is revised, that is unconnected joint is there. In version 8, this is slightly changed. कौन से भाई कौन से क्लास ना અહીંયા એમીમાં છો एमी છો हाँ हाँ तो अभी एमी का क्लास नहीं, ये अंडर ग्रेजुएट का चल रहा है, तो बैठना हो तो बैठ सकते हो. ओके ओके, यू कैन सिट. So this warning is revised in latest version, version 8i. In previous version, if it is unconnected node is there, you will find that warning, that is parallel structure exists. Do you want to make an analysis? Though means that is consider the one node as a one structure and other node other that whole structure as a different structure. So it will give that two structure as a separately. Now this is revised, that is disconnected joint. For removing that, this warning, every facility is available in tool. and that is in orphan node. So that is two option, orphan node. Orphan means that is not connected. It simply orphan means not connected. If you want to highlight or remove, so first it is better highlight. So you are finding some node over here. Go to front view, slightly above. Okay. So I know that this is not important. I have given to explain this tool. I have add that node, so it is better to remove. Okay. Now I am again analyzing. So now I am not finding run analysis. So you will not file run analysis in case of your input and output file is open. Remember that. So below that, check it that below my output file is open. So I am closing this. Now going to analyze and run analysis. So only one warning is less, and probably this you always find there is floor one way and two way distribution. It is not a automatic. Only that warning is there. Now this is analysis. Now we start to that design. Okay. So design is one very simple approach. So you have to have this analyze file. And for design, in last lecture of that Panchal sir, you have told you in design I want to instruct you, if you give that dummy section to that property, in case of that member is sufficient, it will give their beam or column is okay, but it doesn't infer that, means that it doesn't mean that this is just sufficient or most optimized beam section. Means that if it is over design section is there, then it show that design is okay. So for that it required the trial and error solution. That is available in street structure, it will automatically optimize the section. But in concrete structure, this facility with this software is not available. Understand? Everybody understand? I am repeating, if you take that any dummy section, I am assigning 0.45 by 0.45, that is all beam size and all column size. And I am loaded something load, that is dead load, live load, and make a load combination and find that solution. Now I am moving to that, starting the designing this thing. And after ending the design, if I find there is no failure of the structure, it doesn't mean that this structure is optimum structure. Means that it only check whether this section is sufficient or insufficient. It will not check whether it is over sufficient or just sufficient. So base designer, this is designer's job to find out the section, property and its orientation by trial and error through optimum. So that is optimum you cannot do. This is, I can understand this is your automotive approach, but this in this software is not available. And probably in most of the software is not available, particularly for concrete structure, because concrete is a composition of the steel and RCC. So in limit state, if you increase, what is the limit state concept? If you increase the compression zone concrete, for that balancing, it requires the tension zone something steel. Okay, that is your design philosophy of that limit state. So that's why this is not possible for reinforcing concrete. But this is possible, optimum solution is possible for steel structure. So please note then, now we start that design based on IS 456. Now I am clicking on command. Then just like a loading, analysis, and below that it is your design. Design of what? Obvious, everything is concrete, so the design of concrete. So on right side pane it will open another window, concrete design whole structure window. Or other way is through page control tab. Over here this is click on design and then concrete. Will open same window. Now over here the current code is available. Now in select series our code of IS 456. First select IS 456. Now we'll discuss the select parameter and define parameter later on. I am going to directly, after selecting IS 456, I am going to below that tab command. Okay, so though this is available in slab design is also available, slab as an element. But what is the problem? After taking this beam in next lecture, Rajgor sir will teach you, or tomorrow will Nagina Ben teach you. Or in case of that skip by both of the teacher, the next lecture I will teach you. But why we are not teaching? Because this is your ineffective, because in Indian design consideration we are providing that continuous top and bottom bar. We are alternative bending up, not providing unnecessary steel, because our approach is slightly economical. So where in foreign they are either provide the top continuous or bottom continuous slab, just like a beam. Understand? In beam તમે bottom માં બાર number of બાર જ ગણો છો, alternative bent up કે એવું કરતા નથી. So that is exactly same practice of design in other than this Indian condition. So output will available like that. Understand? So we will take one trial section. First I am adding the design beam, just add. Adding the design column, just add and close. So now by scrolling this current code, you will find something. Start concrete design has started. The code Indian design beam, design column. And that is question mark. You can understand what does that stand for? The question mark, this is added into library but it is not assigned to your structure. So again I am going to that command. Now I am selecting this design column, then I am going to command and I am making this checkbox below that checkbox after current code. After current code, which thing you want? Take off. Now what is the take off stand for? Or here it is written, print the total volume of concrete and weight of the steel reinforcement for the beam, column and element designed. This command has no additional parameter. So I am just adding after current one. I am closing this window. Now I am scrolling. Now this is concrete column and concrete take. So understand what is the concrete take? It will estimate the quantity consumed in terms of volume of concrete, in terms of steel in ton or kilonewton. So at the end of the design, it will give that quantity total of a structure. Now what is the beam? Beam that is parallel to x and z coordinate. Okay, so I am selecting this beam. Now going to selecting beam parallel to x, select to beam parallel to z. This is selected. Now assign to selected beam, assign. So beam is this xz plane is in beam. Now this is all, this is selected. Now I am selecting that column by inverse selection approach, by inverse of beam selection. Now I am unchecking this highlight assign geometry. I am unassigned this highlight assign geometry. I am moving to design column and assign to this selected. This is selected to this number of that column. So what is that assign? Move. You will find the number list below that. Now for checking the design, simply again run that analysis engine. One error. What is that error? It is essential to check. So below that error is available. This is the limitation. Write down which of the section will design by STAAD, that is T, and rectangular section will design by B. T or rectangular. Okay, so I am rectifying that column. There are a lot of column that is circular. So I am quickly changing that property. Go to general, property. Now I am removing this property. Or double click this. Okay, those it will open only that. Now I will change the property. So it requires that another analysis. Though still my output file is open. Error is gone away. One warning, you can know that which warning is there. Now for reading that design from output. So this is result is available. Result by step by. So first apply load, then reaction load, then concrete design over here. So in concrete design, I am reading this file. Look at this is your concrete design. First started beam number 100, then design result. M30, Fe415. We have not inputted anything, but the material it is considered by default whatever available. Fe415 secondary. Length 4 meter, that we know. The section that we have inputted. Cover 25 mm. As per that, code IS 456. Now this section detail at top and bottom reinforcement at 0 mm, this is at 1, 2, 3 and 4. This is calculated 1/4 of the section. What is that? So over here the top reinforcement is not required. So it will better we check that bending moment diagram, then we know. So at support you will find the negative bending moment. To compensate negative bending moment, you have a negative reinforcement. In between over here you will not find any moment, that's why no reinforcement. And at the due to that at downward moment you will find this reinforcement. So summary. Now what is summary of the provided reinforcement area? The top reinforcement at 0, 4, 12, 212, 212 it's not required. Over here the reinforcement requirement and this is provided. Though it is not required, it is provided. Why? Why? Any idea? If it is not required, then why have STAAD as provided? For steer up. How can you bind the steer up? At least 4 bar is required at 4 corner to generate the steer up. Okay, so it requires that 2, at least 2 it will take. And the layer of reinforcement is also showing. What is the layer of reinforcement? Okay, in case of your the steel bar, number of the bar is available is 20 mm and that is not fit to provide at one level, then you will switch to other level. So that is your layer. So this is in within one layer. And the shear reinforcement, that is two-legged 150 mm center to center. Now below that what is something is written. Shear design result at a distance d of effective depth from the face of that support. This is your 39 close of that IS 456. What is that effective distance for the shear reinforcement defined? So from support to at a distance d, d is the depth of the section, effective depth of section. Where the section is considered from means that from any beam, from this point to at a distance d, d is a effective depth of the section. So that is as per the IS 456. Now shear design at a 415 mm away from the start support. Why 415 or 715? Why? The depth is new. Now double clicking over here is also give that concrete design result. Now previously before that analyzing it is ended with deflection only. Now it is extended concrete design. Now when I click that this concrete design, it will this available like this. So design parameter over here FY 415 FC 30 depth 0.6. So why this is STAAD has made a mistake. This is why 715. It is from face of support. So what will the column orientation that you have to check? Check the column orientation. So this is 650. 650 divided by 2. 325 plus 600. 450. Okay, this is 450. I'm closing this window. Rendering this view. Beam is considered always from center to center distance. Remember, instead, whatever the by default you will provide, this geometrical design always center to center. Note down why I am talking to this, because somewhere you find that you never find the column as a exposed in wall. You will find always flush. So that you have to change this orientation by editing. Okay, so now what is that orientation of that? For checking that orientation, write down which view it will call you. View, then that is your structure diagram. And this is 3D view of section outline. I'm clicking structure, 3D section outline. I'm selecting particular level. So where do you find that? This all line of that column or beam is extended. So this should be flush like this. Let me make the zoom. So center line of the beam is, this is your red line, and blue line is outline of the section. This is external edge of beam on column is like this. Okay, you will not find any hole created anywhere in frame structure like this, only because of this beam is flush over here, or this column is switched at externally. ખબર પડે છે કે નથી પડતી? અત્યારે આવું ઓરિએન્ટેશન બતાડે છે, સેન્ટર થી સેન્ટર, and by default it will take center to center geometry like that. So it will create over here it will create this kind of the shape. By connecting the beam at this level, it will connect like that, because at the column at this below level, let's have the column view also. Now observe carefully, and this rectangular is column N, and this is your beam. Now column is of size of 600, and this R4, okay, I am looking, not randomly telling, this is your R4, beam is of 450 size. So what will be this projection beyond this line, and what distance I give, then this column becomes the flush at this level. So that is 600 less 450 divided by 2, because at both ends you can find out projection, one end you have to switch, this you have to flush. 75 mm. 75 mm which direction? Better positive x. Positive x. This is at start and this is at end. Now for making the column as a flush in structure, you have a command, write down, this is by default. Same we have gone through, we have learned something, specification. Geometry, command, member specification and offset. I'm clicking the offset. You'll find this window, offset of meter, at which what distance? 0.75 or 75 mm means 75 meter, 0.75 meter at the start, and axis is global. Add. Now again adding, click on beam, you will find offset over here, and at that end that you have to also define of a 75 mm. 0.075 meter means 75 mm. So in library I have added the offset of this column at a start point 0 and at that point 0, means this is, you have to switch whole like that, not only one location. If you make that at one location, it will become the tilted. So this is, you have to switch both levels. Now I am assigning something to that particular column of this years. I am selecting, assign to select. Now I am assigning shears. Now I am looking at outline view, structure diagram, section outline. Okay. Now I am going to top view. Exactly this line is not matched. What I have made the mistake? Now still this is not flush. Okay. Oh, this is your tilted, look like tilted. So this is available in general, specification, and this is, and we have not assigned. Assign to selected one, assign. Assign to selected one, assign. Now I am checking in view structure diagram, that is section outline. Okay, now I am going to a top view, but probably that is look like the flush. So of uneven section that is matching to that column and beam orientation, that you need to flush. Remember this, because the STAAD will consider center to center point. Okay, where we are now, this distance 715. Why it is 715? Effective D, effective depth, the cover is 75. The effective depth is of 600 mm depth beam. What is the effective depth? 600, 575. 575 plus 225. 800. 815. Or other option, that is your other section is of column is 450. So 450 less 25 plus 225. 650. Now that you have to find out, I am unable to find 715. Why it is calculated at a distance 715? And at this location, the calculated design shear force is 59.58 for beam number 100. This is I am reading for beam number 100 detail. And below that, the maximum moment at this location is minus 0.18. And provided 2 leg 8 torque 150 center to center distance. Now this is your end of the design of beam 100. Now like that the column, what is the in column detail it is given. I am simply pressing Ctrl F and writing column in that window. So in column, so what is the available column number 17 design result M30 FE415 FE415 secondary and main. This is what is the required steel. Required steel area is 305. Required concrete area is 38158. So main reinforcement provided 812, that is your 0.34 percentage, and that cross sectional area is 904, and this is your equally distributed. This is a automotive and consider by default value. And tie provided 8 mm dia rectangular tie at 1 and 190 mm center to center, means that is your tie stirrup. So section capacity base result, that is it can carry the axial load 37, moment and that plane Z and Y, both biaxial bending at this value. The interaction ratio as per the clause 39.6 IS 456 is 0.19. And worst load case, over here it is given load case 3 and end joint force, this is 113 PUZ. Okay, at joint number 113 PUZ 3914, MUZ 209, and MUY 158. Interaction ratio like that. Now this is everything is considered by default. Now that we have a problem because we don't like to have that grade of concrete M30, Fe415 depend, not Fe415, Fe250. So that you want to change. So again go to general, in design, concrete design, and now the defined parameter. The purpose of defined parameter is change the default value of the STAAD as used. Okay, so I'm clicking on define parameter. Now if you add now onward, then it will consider after the ending of the concrete design. So it's better you select the code Indian and then you have to apply that parameter, because this parameter should be before that designing parameter. So select this code Indian. Now go to define parameter and click as a after current one. After current means whatever you have selected, it's considered as current. Now this is your phrase. So what is this means? I am reading one by one. Before that, write down the link for remembering. That is not necessary what is the default value. Not necessary to remember this each value. You note down the link. Link for checking the default value of IS 456. So go to help, contents, help, contents, click on contents, it will open another helping window. In that, international design code, in which Indian code, in which concrete design per IS 456. And in which design parameter. Previously in older version, this is available on column design. So what is the different parameter? It is better we learn from this. Okay. So this is parameter name. You will find this underline, you will find the name in this window. So I am giving over here, adding define parameter. So FYM, FY main. Over here you will find so by default it will consider FY main. Mains means that main thing in design of flexor. So that is which reinforcement? Tension steel, compression steel, and secondary reinforcement. FY secondary is that is your hoop and shear reinforcement. So that is 415. Both are 415. So primary and secondary you understand, and consider by default 415. FC by default M30. So if you want to edit FC, I am minimizing this. Now I am changing FC. What is that value FC? That is written 27,000 something kilonewton per meter square. Now I am changing to M25. So let's better 25,000 kilonewton per meter square. Or let's check, this is in function F2, other unit is available. This is not available. So it's better if you note down in Newton per mm square, close this window, write down one step for in between changing the unit. In between the design operation for changing unit, go to tool, set current input unit. Make as a millimeter and Newton. Now press as a OK, set current input unit. Now go to define parameter. Understand? Tool, set current input unit. Now click the FC, you will find Newton per mm square. Okay. Now this is grade of concrete. We have a problem. This is not non-available grade with the conventional material. So let's keep it 25. Now add. I am switching that other parameter clear. So clear, what is the clear? This is your clear cover. Clear cover 25 and 40. So if you want to change the cover, you have a parameter that you have to add as a clear, and that you have to assign the particular thing. The minimum main. So minimum main reinforcement section size, that is not less than 10 mm. Maximum main, that is 60 mm. So that we have a problem. Not even India is available more than 32 mm. So we are changing maximum main, instead of even 32, let's keep it as limited to 25 mm. Maximum main is 25 mm. I am adding. Now I am going to this window. Next is minimum secondary 8 mm. That's okay. So this is secondary means stirrups and another in one way slab, anchor bar, one way. You are calling anchor bar one way for. So in one way slab only main reinforcement is in which direction, longer or shorter? Longer. Shorter. So anchor means just anchoring this bar into its original alignment. We are providing some distribution steel, or in other words you are calling that distribution steel. That is also secondary. So that is 8. A maximum secondary 12. Let's okay. This is okay. Instead of you are not satisfied, make it as a 12 mm to bend and work. It is problem, create the problem. So maximum secondary I am changing, instead of 12, 10 mm. Now next, is a bracing. I am reading this. For beam design, the by default value is 0. What does that stand? A value of 1 means the effect of axial force will be taken into account of beam design. In generally, beam is designed as a flexural member, not an axial forces we are not considering. You are taking the bending moment as an input and you are finding out the requirement of the steel. You are not taking axial force anyhow. So if you give that value 1 means the effect of axial force will be considered in beam design. By default is 0, so by default is okay. Okay, we are not concerned about that axial force in beam. Column design. Corresponding to the terms brace and unbrace. Described in note 1, 2 and 3 of the clause 39.7.1 of IS 456 2000. A value of 1 means the column is unbraced about the major axis. What is column unbraced? The value of 2 means column is unbraced about the minor axis. And column value 3 means column is unbraced about the both axes. And 0 means 0 means 0 for beam is not considered design of axial force. Now 1 is means that column is unbraced about major axis. Now what is that major axis? So its column is like that. Probably the axis where the moment of inertia is higher means that if the column is like that, if I like to bend along this plane is difficult, but I can bend along this plane. You can finding that. So the major axis in flexor, I am finding the deflection. Okay. This is your minor axis. You can. This is your minor axis. So this axis is minor, and this is your major. So where the moment of inertia is higher, that axis are called major. So everything over here 1, 2 and 3 for making the column as a unbraced. So what does 0 stand for? If you take the 0, then means column is braced both the side. Understand? So what is that bracing of the column? So bracing of the column means if you apply the lateral load like that, in frame, if the other column is connect, or other beam is connected and other side of that, if you consider the effect of this beam, it will not allow to deflect, okay, because it will provide the support from other end. But if you don't consider this effect, then it will act as a cantilever beam. But in frame structure you will find along this line, the beam is connected. Are you understanding? So naturally the column is in frame structure, at internal column all are braced because they have a support at lateral direction. So at external corner, if you want to give that unbraced about that major and minor axis, you can give that. So let's have unbraced. In which axis it create the problem? Unbraced. Major or minor? Means in minor axis, because if this is not supported in this direction, the strength is much higher. But if it is not in this direction, it is supported, we will create the. So that the problem is in major or minor. So which parameter I have to add? Value of 1 means column is unbraced about major axis. Value of 2 means or both. So let's have add 3. So that is BRA. Command name is underline BRA. I am adding BRA for column only. Beam, that is okay. So BRA. Local Z direction. I am adding. Over here, more specifically written 1, 2, 3. And beam, column, brace in both directions. I am just adding. Now I am moving to that next, the ratio. The ratio of maximum percentage longitudinal reinforcement in column. What is that maximum percentage for FE415 in column? Now 4 is by default. कईक तो बोलो, कईक तो by trial and error will let's find out the answer by trial and error. Next 6 diploma student, what is that? 6. So 6% of the reinforcement, longitudinal reinforcement for making the concrete and reinforced concrete as a workable, but permissible 8. But that is not feasible. If you provide that 8% of the cross-sectional area, you will not place that concrete properly. So for workable concrete, the limit is 6. Otherwise, that is your 8%. Okay. So let's keep this is 4. It is quite higher. From designing, I know that I am keeping as unchanged. Okay. This is by default 4% is okay. In case of the where this required to change, in case of the beam, the STAAD has another limitation. It will not design as a doubly or singly reinforcement. You know that limitation with the material and grade of the steel, you can go up to certain limit. Otherwise, you have to go to doubly section, you have to reinforcement other zone, that is your compression zone. That is your approach of limit state field. ફર્સ્ટ ઇન્ટરનલમાં આવું હતું ને, પ્રોબ્લેમ પણ પૂછ્યા હતા. So in this it will not automatically consider two-way design. For that you have to not design as a two-way reinforcement. For that you have to make the trial and error. Remember that. દોઢ વાગી ગયો નહીં? હા હા. Okay, it is better we stop over here and continue from the next. I am starting in case of the